Welcome to a brand new episode of the Clear to Send podcast. This is Francois, and I'm here this morning with Roel. Hey, Roel, how are you?
Hello, good morning.
It's nice to be, back recording with you here. And today we are continuing our series on Wi-Fi hardware and devices. We talked about the overview of Wi-Fi access points. We talked about choosing the right antennas. And today, this episode will be talking about, why Wi-Fi devices are not all the same. And so we'll talk about, why we have some of those disparities in the Wi-Fi landscapes.
Yeah, and I think
Uh,
it's important to realize this when you are looking at devices and understanding what you need to support, um, what kind of features you're looking at. So, very
mhm.
key to think about. And I don't think people talk about the client devices as much, right? It's just kind of an afterthought.
Yeah, that, and I think as network operators in our position, we sometimes complain, about client devices not all being the same, not all supporting the same set of features, and it kind of drives us crazy because the client devices do take important decisions on the Wi-Fi. Um, but if you place yourself on the other side of the spectrum and you are actually the person building the product, then it makes sense that different product will have different Wi-Fi specifications because of their purpose, right? And if we were to kind of summarize the episodes in one sentence, it would be the reason why devices are not all the same is because they are built for different purposes. Some access points are built for indoor, other ones are built for outdoor, some are built for the enterprise space, other ones are built for the home environment. Same thing for the client. Some are built for VoIP, some are built for just IoT. So because of the purpose of the equipment, then it makes sense that they don't all have the same Wi-Fi
Yeah, yeah.
specifications.
They're purpose built, but then
Yeah.
it makes it difficult for us as Wi-Fi engineers to design to
Mhm.
specifications, to design for requirements when all your client devices have different sets of requirements.
Yes, exactly. And we have to just keep that in mind when we design. We have to keep that into consideration for sure. So let's talk about the access points first, right? Because talk a lot about access points. We're the one that have to choose which access points to use, and so we know that even looking at the enterprise vendors out there, we have a wide variety of access points that we can get. And it's always, the question is always, okay, which model do I want to choose for my environment? And usually what we'll see is that access points they'll have, they'll be different in different fashions. They'll have different form factors. They may have different hardware component, different antennas, different type of antennas. They may have different Wi-Fi chipsets that allows them to have additional features, and then they may also have other hardware and software features that are added, that allows them to kind of stand out for specific features like location, IoT, or whatnot. So if we look at the access points, we kind of have to think about what's going to be the usage of the access points, in which environment do I want to install that AP in, and how do I want to use that AP for which purpose. And then that can help us to choose the best access points to do the job. And it's like Wi-Fi design, there's not one good answer for every question. You may have different models that you can use in different environments, as long as you can understand and you have some sort of reasoning behind it. Um, it, it, it you know it, it should make sense.
And I think understanding what those different types are can help lead to a better design and also help you determine what your budget may be. Because most environments, they tend to think about just the omnidirectional AP, but you could lend yourself to a better design by picking a different AP. But it just depends on what your requirements are, what you're trying to do for capacity, a lot of different features available. And when you look at a vendor, it is important to look at what they have available. Some vendors are not as flexible with the types of APs they have. They may just have one omnidirectional AP and maybe not one with a built-in directional, for example, or maybe you want one with external antenna capabilities, but maybe the types of antennas that you could use are just not the ones you need in your environment. So it gets tricky, but I think it's just important to know where to look so that way you have that flexibility.
Yeah, and I think one typical example of AP form factor is the if you compare the typical AP with omnidirectional antenna that you install under the ceiling, that's typically like the go-to AP. Um, you can compare this to the hospitality APs, and the hospitality APs they've been built for hotel rooms, dorms, maybe small apartments that we may have in like senior living facilities, and so in these environments, we may have limited mounting location for the APs. We might not be able to install it under the ceiling and all of this. The cabling is complex, expensive. So some vendors built those hospitality APs that you pretty much install on the wall. And they included like usually you have a little switch, so you have additional Ethernet ports, and also the antenna has been built differently, so it has like a little bit of a directional aspect to it. So it's not like a fully omni. It can redirect the signal a little bit to kind of get the best coverage, even if the AP is installed on the wall, right? So understanding that the form factor is different because of the limitation of the installation and where it will be installed, right? More often it's installed lower to the ground, so the antenna will kind of shoot the signal more upwards. So understanding all of this can help us understand why all access points are not the same, are not built the same.
Yeah, and take a look at access points in the next hotel room that you visit. Take a look at where the access point might be. You may not see an omnidirectional AP on the ceiling just for aesthetic reasons, right? It kind of bothers people, especially those who don't
Mhm.
know Wi-Fi. They might not know why that thing is there in the ceiling and has a bright LED bothering them in the evening. So then you have these hospitality APs. They're wall mountable, and they can hide behind certain like couches, or a lot of times you'll see them behind TVs or near the desk. And so just take a look at that and see and think about, okay, why did they select this AP? And so that's just important to look at.
And then another reason why we have different form factors of access point is because, like you mentioned, like some of the access points are built for a specific need or to meet a specific requirement. The one I have in mind is, sorry, lately, with the 6 gigahertz band and the difficulty of using external antennas, we're starting to see these access points with integrated directional antennas, right, with different angles. And these APs are built because there's a need for it in the market, right? And we have regulations that don't necessarily allow us to use external antennas for 6 gigahertz in some countries. So that market need kind of leads to having also different form factors and different type of APs that we may be able to use in certain environment. If I need a more of a directional antenna in some environment, I can go with that model, that new form factor. So another reason why we have different devices with different form factors, because some of them are built to meet like a very specific need in the market. Yeah,
Yeah.
other ones are built just because vendors want to try to differentiate themselves, right? So
Yeah.
they'll try to come up with, you know, um, a new antenna or new patterned antenna that they kind of create in the R&D labs. Some of them will come up with, new functionalities so they can better integrate with IoT systems, and they'll try to kind of differentiate themselves from the competition. And so that's also a reason why sometimes we'll see different APs with different form factors. But
Yeah.
it's like healthy competitions between the vendors.
Yeah, and usually what I see are those APs are a lot larger, and that's because they just have a lot more radios in there.
Mhm.
Maybe they have a special BLE antenna, or there's some extensibility with USB ports or another port, adding additional Ethernet ports on an AP. So it just makes them larger as an access point, but it usually means there's additional features that you could utilize.
Mhm. Yeah. So, in this episode, we've kind of focused mostly on the enterprise APs. We didn't really cover the like the more consumer or home access points. But these are this is like a whole other market. So you'll see a whole other set of product and form factor and prices as well for this market. But once again, it's because it's built for different purposes, right?
Yeah,
So why don't
exactly.
we transition to the client devices because that's
Oh,
where
yeah.
the fun is.
Yeah, that's where it gets more complicated.
Yeah, and in the client devices, it's interesting because the form factor is like we can have different, like a wide range of client device form factors because we find Wi-Fi everywhere nowadays. You can have Wi-Fi in larger electronic equipment like a laptop, for instance, where you may have more room to put an antenna to have bigger Wi-Fi chipsets and cards and all of this. But we also find Wi-Fi in smart watches or equipment that are tiny where it's not as easy to kind of put a Wi-Fi radio and antennas in it. So we're gonna have different form factor which will impact the type of Wi-Fi performance you can expect to get from the Wi-Fi.
Yeah, and I find that if it's a smaller device, the lesser quality of the Wi-Fi device.
Mhm.
Just because it's a smaller form factor, you can only fit so many antennas and the kind of radio you can fit in there. And so maybe the receive sensitivity is not as great compared to a laptop, right? So laptop more fuller capability with Wi-Fi there because of how much space you can where you can put the antenna in a more ideal location, or even capabilities of power, right? If it's going to go on battery, it has to conserve some energy there, some power in order to still operate.
Mhm. Yeah, and talking about this, one thing you could kind of study when you study clients is see what type of antennas, where the antennas are located. um,
Hmm.
I took a picture this week and I went to this store. It was like a clothing store, and when I went to pay at the POS machine, the POS machine was kind of open, and the two Wi-Fi antennas were outside of the of the body of the equipment. And I was like, I told the guy, "Can I take a picture? That's really interesting." And the guy is like, "Sure, why not?"
Probably thought you
um,
were a weirdo by asking like.
yeah, exactly. But what what was interesting is you could the antenna was not like a circuit printed antenna. It was like a dedicated a copper antenna, and you could see the little coax cable coming back inside the
Mm,
unit. Yeah, so and that's because the POS unit was a little larger, right? They have room
yeah.
to put those dedicated antennas. But if you think about a smartphone, everything will be most likely circuit printed and take less room. So
Yeah,
maybe
we don't have
less volume.
antennas sticking out of cell phones anymore.
Yeah, we used to
If
have that.
Yeah, if any
Yeah.
of you are old enough to remember those, extend the antenna so I can get better
Yeah.
signal.
Yeah, so
And
that's no, that's one thing that's going to impact the Wi-Fi. And
mhm,
in most environment, I would say it's not that critical. But if you're thinking about like industrial environments,
mhm,
warehouses, factories, sometimes you're just it's really important to have good hardware because you can maintain the reliability of the Wi-Fi connection. And that can make a big difference on the end user experience because in these environments you don't need high throughput, you just need to have a reliable connection, and that can make a big difference to have good hardware that
yes.
makes that are able to kind of provide that reliability.
Yeah, and going back to where you were talking about the location of the antenna for these client devices and seeing this on that point of sale system, it is important to know where the antenna is on the system because when you go and place this device in the environment, you may not want to lean it up against something maybe metal or put it into a metal enclosure, or maybe there's other obstructions surrounding the antenna. So it's good to know where that antenna would be because if you do have to troubleshoot, let's say somebody moved a client device to a location and then all of a sudden the Wi-Fi connection is not as reliable, knowing what is around that antenna would be very useful for troubleshooting.
Mhm. That's a good point. And so far we've only talked about like the form factor, the hardware, but another reason why we have different Wi-Fi client devices is because of the chipsets that they use and the Wi-Fi drivers that are built on top of these chipsets. And that can have a big impact on, the way the device operate and the end user experience. Um, so first we can
Drivers,
talk about
especially.
the yeah, drivers especially. So let's talk about chipset first because chipset
Okay.
they can come first after the hardware, and at the chipset level, this is where you may have differences if they support different certifications from the Wi-Fi Alliance, or if they support different features, or some chipset they're not even certified against the Wi-Fi Alliance. That can happen. And so you could have devices that, if we take the example of Wi-Fi 7, this is kind of like in the news right now. But not all Wi-Fi 7 devices are equal, right? Some of them will not support 320 megahertz wide channels. Some of them will not support 4K QAM. Some of them will not do MLO. So the chipset will kind of, this is where they do like the low level implementation of these features, and not all of these features might be available in all of the Wi-Fi devices. So you may see features that are not available for everyone. um, and you tend to see that also in the cheaper Wi-Fi chipset. Then maybe you'll have less features available. Maybe you won't have 6 gigahertz. Maybe sometimes it's only 2.4. So the chipsets will kind of drive what you can do then at the driver level. It's becoming a limitation for the device
Yes.
manufacturer.
Yeah, and I think also when you think about the manufacture of the chipset, sometimes the availability of see, I'm not someone who programs or develops the software that interacts with the chipset, but sometimes the manufacturer maybe just doesn't have everything available for the vendor to program into the driver. And so
Mhm.
a lot of times, like you were saying, there's no support for MLO. I think maybe it could be something that would be available in the future when you
Mhm.
update. I don't know what they call it, the software of the chipset, and then make that available to the vendor. I think sometimes that could be the case because when you do look at the specifications or the standards, you should see what is supported and what is mandatory. And so, yeah, so a lot of devices won't do 320 megahertz wide channels because in the standard, you only have to support, like, it's not mandatory, but you could support 320 megahertz wide channels. So that's why it's important to, one, know what's in the standard for Wi-Fi 7, and then two, look at what is actually supported by the device according to the standard, right? And I
Mhm.
think that's the harder part, being that Wi-Fi 7 is so complex compared to the previous protocols.
Yeah, and I think adding to what you're saying, I think the going back to the chipset manufacturers, they also build different chipsets for different purposes, right? Because if you want to build like I don't know, if you want to build a laptop, you will probably need a different Wi-Fi chipset than if you want to build an IoT sensor that will connect to a machine and report some telemetry. So these chipset companies, they also come up with different chipsets, um, and once again, because they have different, they are built for different purposes. Some of them might be focused on throughput. Other ones might be focused on saving energy. So once again, it's the reason why they build those purpose and the use that we can make out of them. That's the reason why we have different chipsets with different supports. Yeah.
Yeah. And this is why you would test these devices before purchasing hundreds or thousands of them, just
Yeah.
to understand what is the feature set that they support on there, how do they interact with Wi-Fi and APs, how do they roam, that kind of thing. And that kind of dovetails into the drivers as well.
Hmm. Yeah. Does it meet your use cases? Yeah. Yeah. So the Wi-Fi drivers is also something that can impact the behavior of a Wi-Fi client and the user experience. Um, And the reason why the drivers are important is because, Wi-Fi devices, they take very important decisions when they operate on the Wi-Fi network. They decide which AP they want to connect to. They decide when it's time to look for a new AP and when it's time to roam, and they decide which AP they want to roam to, right? And these three decisions, it's not much, but they are very important decision for the user experience, right? If you can connect to the proper AP, the user will notice it, or if it takes too long, the user will notice it. If you can't roam properly and you can find a new AP, same thing, the user might notice it. So it's very important that the driver is implemented properly and that these decisions are done properly if we want to ensure a good user experience. And this is what we'll see most of the time in the field.
Yeah, in a lot of cases, you may not have any control over what drivers are installed on the client device. So for Apple devices, that's largely controlled by Apple. But Apple does provide you with the documentation that has details on how and when the Apple device will roam, or what triggers certain things. But when it comes to other manufacturers and their chipsets and drivers, uh, sometimes you do have to update those manually because there are bugs in them and improvements that they've made. So that for like Windows devices, that's where I would be updating more often and trying to understand what driver version they're running.
Hmm. Yeah, so I think that kind of explains why different devices are not the same. Um, for me personally, one day I met an engineer that used to work for a company that would create Wi-Fi devices. I can't remember exactly which one it was, and I was kind of complaining about different devices not supporting this, like the usual rant. And then he kind of explained it to me. It's like, the way these devices are built is they're built for a very specific purpose. So if you take, for instance, like a Vocera badge, right, that you would use in a hospital. These are built for the nurses and the doctors, right? And the goal of these badges is to be able to quickly communicate with other people, support voice over IP, and make sure that it's seamless in the workflow of the nurses and the doctors. So at the Wi-Fi level, the decision that they're gonna take at the Wi-Fi driver level will be driven by this purpose, right? Um, and so that's why the drivers of a Vocera badge is not the same as the drivers of an iPhone, because they're not built for the same purpose. And it makes total sense if you look at it from that angle. If you look at it from the infrastructure angle, like, why don't they just support everything? Everyone would be happy. But I think sometimes we have to look on the other side of the spectrum, because it helps us understand why different things are built the different ways. And then that's the way it is. We kind of have to understand it, study it, and then work with it the best that we can on the infrastructure side.
Yeah. So the way I would end this is, it's easy to understand the infrastructure side because of how much documentation there is for access points, controllers, and the protocols. But what is more difficult is understanding client devices and how they work. Why is the same Apple device not operating the same as another Apple device? And a lot of testing would have to be done to truly understand the characteristics of these devices. And for some of us, that's a lot harder to do because of maybe a higher ed uh, environment where you have every single type of device, including consumer level devices like gaming consoles. But for an enterprise where you can control what type of devices are being used, then you have a better grasp over understanding how these devices work. And so you could become more of an expert for how Wi Fi works on, say, these Dell laptops, for example.
Exactly. Well, thank you, Roel. Thank you for that closing statement. It was pretty good. You guys, you let us know if you found some wild clients in the wild. I would, we would love to hear about those stories. Um, and then we'll share all of this, on the website as well. If you go to clearsend.net, you'll see this. We'll add this video as part of the Wi-Fi hardware and devices series. And we'll see you guys in the next episode where we'll talk about the different Wi-Fi tools that you should keep in your bag as a Wi-Fi engineer. Thank you
Awesome.
for
Thank you, guys.
listening, and we'll see you guys in the next one.